People definitely love speed. The faster a person moves, the more exhilarated they become. Today, humanity has managed to develop incredibly fast airplanes, ultra-fast fighters, super-fast high-speed trains, and so on. However, the universe has something up its sleeve that's faster than anything we've achieved, and this is light. Have you ever wondered if it's possible to travel at the speed of light? Hello, dear friends. In today's video, we would like to tell you about the speed of light, whether it's achievable, what a person would see at that speed, and if it can be surpassed. But before we dive into that, we'd like to ask you to subscribe to our channel and hit the bell icon to not miss out on our new interesting videos about the mysteries of the universe and our planet. Let's start with a bit of theory. The speed of light in a vacuum is a constant value known to us quite accurately. Light travels at a speed of about 300 million meters per second. This is the speed of propagation of all electromagnetic fields in a vacuum, including radio waves, infrared, ultraviolet, X-rays, and gamma radiation. According to special theory of relativity, introduced by Albert Einstein at the beginning of the last century, nothing material can move faster than light. But why is that? The formula known to probably most people will help us find the answer to this puzzle. In our case, we'll have to transform the formula and it will look something like this. If the object we plan to accelerate moves at the speed of light, then we can replace v with c. It can be understood that if you decide to accelerate something to the speed of light, it will require an infinite amount of energy to actually achieve that. On the other hand, light, which consists of photons, moves at such a speed. This is all because photons have no mass. Therefore, they don't require any energy to move. Nevertheless, theoretically, it is entirely possible to travel at 99.99% of the speed of light. So, what would a person feel while moving at this speed? For a person moving at a speed close to the speed of light, time will significantly slow down, and the faster the object accelerates, the more time will slow down for it. For example, a person is aboard a spacecraft that covers a distance at a speed equal to 99.99% of the speed of light. From the perspective of an Earth observer, the spacecraft will take approximately 12 months to reach a planet 1 light-year away. However, the perception of the astronaut himself will be such that it took him just over an hour to cover that distance. One advantage is that the astronaut won't age much. However, there are also some difficulties. According to the theory of relativity, the mass of the traveler's body will increase as his speed of movement increases. A person whose body weight is 65 kilograms, traveling at 90% of the speed of light, will feel like he weighs 150 kilograms. And with each subsequent percentage, this value will exponentially increase. Moving at such speeds, the traveler will see the universe flying toward him through the window like a streak. Stars approaching the ship will appear as blue streaks, while stars receding will appear red. This is because the wavelengths of light emitted by stars ahead would become shorter for the observer. Conversely, the wavelengths from stars behind would lengthen, and it's the wavelength that determines the color perceived by the eye. However, after surpassing a certain mark on the cosmic speedometer, the traveler will plunge into darkness. The spectrum of waves emitted by stars for an object traveling at such speeds will no longer be detectable by the eye. But what if a person could move like a photon, precisely at the speed of light? What would they see then? As mentioned, the higher the speed of an object, the more time slows down for it. Based on this, time simply does not exist for a photon. Whether it's an hour, a year, or billions of years, any period of time for such an object equals zero. If a person were flying at the speed of a photon, they wouldn't see anything. This is because to see something, you need time. And if it equals zero, then no actions from the flying object are possible. So we've understood that a person or any other physical object will never be able to move at the speed of light. Now, as strange as it may sound, let's find out if we can surpass this speed. The limitation that nothing can move faster than light isn't as universal as it seems. The universal speed limit, which we usually call the speed of light, is fundamental to how the universe operates. It's hard to grasp if you've never heard of it before, but scientists have discovered that the faster you move, the more your spatial dimension in the forward direction compresses, and the slower your clocks tick when viewed from an external observer's perspective. In other words, space and time are not a fixed backdrop against which everything happens as it always has. Instead, space and time can warp. A reference frame with zero length and no progression in time actually constitutes a reference frame that doesn't exist. Therefore, this tells us that nothing can move faster than the speed of light for the simple reason that space and time effectively do not exist beyond this point. Since the concept of speed requires the measurement of a certain distance traveled in space over a certain period of time, the concept of speed physically doesn't exist beyond the speed of light. In fact, the phrase faster than light is physically meaningless. However, this is only true on a local level. A more precise formulation of the principle is, nothing can locally move faster than light. This means that we can indeed achieve effective speeds exceeding the speed of light if we use non-local scales. For example, if wormholes exist, we could use them to shorten the distance from Earth to Alpha Centauri. Compared to the small amount of light that has traveled from Earth to Alpha Centauri and hasn't passed through the wormhole, you would travel faster. In other words, you would be the first to reach the star. This is allowed because you never exceeded the speed of light locally. If another beam of light was directed from Earth to Alpha Centauri and passed through the wormhole alongside us, we wouldn't be able to outpace it. We've talked about wormholes in one of our previous videos, which you can watch by clicking the link in the top right corner. The very first light in the history, cosmic microwave background radiation, is distant from us by 46 billion light-years in all directions. Considering that the Big Bang occurred only 13.8 billion years ago, one can understand that most of the universe visible to us is already flying away faster than the speed of light. But how can we see the light from any galaxies moving faster than the speed of light at all? How can we even see cosmic microwave background radiation? The light emitted by galaxies is moving toward us, while the galaxy itself is receding from us. So photons emitted by all the stars in the galaxy can still reach us. These wavelengths of light stretch and slide further into the red end of the spectrum, going into infrared, microwaves, and even radio waves. Over time, the photons will stretch so far that we won't be able to detect the galaxy at all. In the distant future, all galaxies and all radiation we see today will disappear, and they won't be detectable. Astronomers of the distant future won't know that there ever was a Big Bang or anything beyond our local group of galaxies. Due to the lack of data and undeveloped technologies, people won't be able to approach nearly the speed of light for a very long time. However, someday it will definitely happen and provide humanity with answers to many questions. Thank you very much for watching. If you enjoyed this video, don't forget to like it and subscribe to the channel to be the first to see our new videos about the mysteries of space. Write in the comments what you would like to learn about in the next video. Thank you and see you next time.